All right, welcome back to part 3. This video is going to focus on creating an actor, which will be a button that the character can step on using dispatchers to control how the logic flows between the buttons and the doors, and it will trigger these doors to open and close. And then we will start some preparation for also creating a lever that the player can interact with. And let's just get right to it. Let's begin in the blueprint folder and create a new folder. We'll call it Interactables. In this folder, right click and create a new blueprint class. This will be a actor class. Call it BP for blueprint, interact. Open up the interact class. So this will be my base interact class for all of my interactables. I'm going to leave it plain right now. I want to right click this class and create a child of it. And we're going to start with, let's just create a simple button. When I open up the BP button, the parent class is my interact class. When I create higher level events and functions, I'll do it in the interact class. But for visuals and textures, materials, effects, all that, I will do it in the child class. And if I need to cast or get a reference to use functionality, I can cast to the interact class and it stays fairly light and doesn't require loading so much stuff. Go to add and let's start with a static mesh. In the static mesh on the right side, search for a cylinder. Go to the front view and let's scale this down a little bit. Snap the scale to a 0.1 grid and align it something like this. And then I'm going to right click the static mesh, duplicate it, rename this to the button, parent it to this one here, scale it in a little bit, move it up one notch, and from the side, also scale it in a little bit. In perspective mode, it looks something like this. So this will rest on the ground, and this is just above the ground, and we're going to press this down. I'm going to scale this a little smaller. Something like that. Call this mesh button base, and button. Compile and save that. Let's drag it into the level. It's way too small right now. Let's go to our character and drag the character in. Go back into the button actor. At the base, make the scale 2 or 3. Maybe 2.5, and it'll scale up everything. Compile and save that. And back in front view, make sure the base rests on the ground. We can go one notch up so that it sticks above the ground, something like that. Now we need to create a material for it. In our materials folder, we should organize these materials, so I'll create a new folder, a collectibles folder. For the brick, coin, and star, I'll drag just those into it, and then I'll create another folder for switches, which includes like buttons. Just right click off the base, create another material instance, MI, this will be a button, drag that into the switches folder, right click on the button and duplicate it, and this will be the button base material, the base of the button. So now in the button actor, let's assign button base, and then this will be button. Compile that and save. Let's edit these materials. For the button, I want it to be probably red color. For metal, turn off the metallic, roughness. I think we want to turn down the specular, but keep the roughness low. Something like that looks decent to me. Open up the button base, and we're going to do, what kind of color? Maybe like a white. Turn off the metallic on that as well. I think I have my scales not uniform. They're a little oblong here. There we go. Now it's rounded. So now when the character hits the top of this button, we want it to press in. So in the event graph, remove these events, click on the button, and on component hit from the other actor pin, drag off, we'll cast to the BP first game character. This will check to make sure it's our character hitting the button. In the interact parent class to this blueprint, let's delete the nodes in this actor as well. What I want to do at this point is create a event dispatcher. So down here, we'll hit the plus sign and just call this on, and we'll create another one called off. Event dispatchers are a very powerful tool. It's a way for other actors to subscribe, and anytime we call the on event, whoever is subscribed to this actor's on event will do an event. For example, a door will get the reference to this interact actor, bind to this on event, and whenever this on event is called, that door can open or close. With these dispatcher events created at this base level in the button, I can now call them. They won't show up here at the button level, but they do exist. So if I right click anywhere and type call on, it shows up and it's going to call the on dispatch. We'll also just hit a print string here and say on. Let's just test this quickly. If I come here and hit play, run on the button, on is triggered. The reason it's triggered 4 times is because of components. We'll add a do once node here to prevent the duplicated calls. Now, if I do that, it only happens once. Let's go back into the Interactables folder and create one more actor. Let's make another child class. And this maybe can be door. I'm going to show an example of how this door will use the dispatcher to function. So open up door, and in the event graph, we'll remove these nodes. The first thing we need is to set the reference for a lever or a switch. In the variables section, we'll add a new one, and I'll just call this switch. And in the type, now we can look for BP interact, and we'll get an object reference. This now creates a hard reference to the interact class, which is a very light class. All it has is a couple dispatchers set up at this moment. Anytime we have the door loaded into memory, it's going to also load the interact actor into memory. With this switch reference, we need to make it editable and expose on spawn. Whatever object reference we set this variable, we want to subscribe to its on event. In the event graph, we will do begin play, drag the switch into the graph, and to subscribe to its dispatcher, we hit bind to on. Calling the dispatchers on and off was probably a mistake, but anyway, it's right here under the default bind event to on, and we can also do bind event to off. Now how this works is we actually need to create an event in our door that will be bound to this event from the switch. So if we drag off these event pins and do custom, add a custom event, we can now call this door open, and we can do another one here, door close. So on begin play, we bind these events to each other, and anytime the switch is on, the door opens, and anytime the switch is off, the door closes. And for testing, we can just print string, door opened, and door closes. Let's add a static mesh to this real quick, and we could just create a cube, scale it to look something like a door. And something like that is fine. Drag this into the world. That's a very small door, so this needs to be about a scale of 2. Go back into the door, static mesh, scale. So if it's 0.1 and we want it to be double the size to 0.2, go back to the front and drag this up, compile, save that. That seems like a decent size. Still might be a little small for gameplay purposes. Just make it a little bit wider. That'll be fine. Set up a quick material. I'll do a new folder, door. I'm going to duplicate the button material, drag it into my door folder, rename it to MI door, and the color can be this orangish brown, and assign it to the door. Before this will actually talk to each other, we set up the functionality, but we need to actually assign the reference in the door actor here. This is just a type of variable, but it's not actually getting a reference to anything in the world just yet. That's why we needed to expose it and make it editable. So what we need to do in the level is with the door selected, on the right, we now have the variable exposed, and we just drop down and we can see we have both the button and the door available as options because both of these are of the interact type. They both inherit from BP interact. So I'm going to say the button, this button is this actor right here. So now that I've assigned the variable this button, on begin play, the door will subscribe to this button's on and off events. I'm going to delete this character reference there. Let's hit play. And we can see the button is on and the door opens. And it does it the one time because we have the do once node. So if I duplicate the door and have two doors, my duplicate also has button referenced. Now both doors will open from the one button press. I can have as many doors as I want, all open from the single button. And I can also create more than one button. And let's say there's a door over here that opens from the other button. Let's go into our door actor, and off the print string, we'll do append. We'll right click and get a reference to self. And then in the B, we hit space, opened, and we do the same thing. I'll just copy all these nodes, paste them here, plug it into there, but we'll change opened to closed. Now we'll be able to tell which door is opening and closing. Instead of 2 seconds, I'll make it 10 seconds. Let's test this out here. So if I go to the left button, there will be 2 doors opening. And if I go to the other button, door 3 opens. So with just this simple setup, we can already do some very creative level design with buttons and doors. Before we get too much further into this, let's go into each of these 3 actors that we created and turn off the tick events because we do not need them. In the base interact actor at the top level, turn off tick. Go down to the default root of it, turn off tick, compile and save. In the button, the top level is already off because it inherits from the interact actor. But then below that, we need to turn off the ticks, compile and save. And then in the door, the same thing here. Top level inherits from the interact actor, but the other levels, we'll just turn these all off. So now tick is turned off for all of those. Save the project with how it is right now. Let's get working on enhancing these a little bit better. Let's go back into the button blueprint. We want to animate this button so that when the player steps on it or when this is activated, the button will press inward, press down. It's going to go into the base. And as we can see, the base, it's not going to look too good right now. So we want to cut out a circle for where the button's going to depress into. Let's go back to the level here and just take one of the buttons and drag it into the world. Let's raise it up slightly so we can see what we're doing. Go to modeling mode, go to model and Boolean. What it's doing is taking the button and cutting out the shape from the base. If we scale it, we can make a deeper hole. It could be moved. If you move it too far down, it's still getting cut out, but now the entire button's inside of the base, so it's hollowing it out. So we don't want to necessarily do that. I think I'll just do something like this, and I'll hit accept. Now this is a new shape, and it has 2 materials, and it's put it in my generated folder. Over on the right side, I'll click this little magnifying glass with the folder icon. It'll take me to it. With this selected, I'll just hit F2. We'll rename it to S for static mesh, button base. And then I want to put it in my meshes folder. new folder, Interactables, and I'll drag this new mesh into my Interactables. I can delete this from the world now. And then back in the button blueprint, we're going to select button base and search for button base. This is overly large because the scale, we had set it to 2.5, 2.5, 1. Unlock this and make it 1, 1, 1. The button itself needs to be rescaled to 2.25, looks about right. If we depress the button, it can go into this little depression we've made in the base. Before we do that, let's compile and save. Go to Meshes, Interactables, and let's open up the button base. Drag this up here, go to Show, Simple Collision, and that's how it's going to look. So the player right now will stay over the top of this base. They will not sink into it. To do that, we'd have to customize the collision and add a lot of collision boxes around the edges here. Collision must be convex holes. If I delete the simple collision by selecting it and hitting delete, and then do collision, auto convex collision, hull count's going to need to be higher, max hull verts is going to need to be higher, precision's going to need to be higher, hit apply. This is what it's doing automatically, which is pretty decent. If I go into the level and I drag the base in here, lower it to the ground a little bit so the player can go into it, hit play, you can see the character can go into the center. So that was just a simple auto convex hull collision. Going back to the geometry, what this did, each of these shapes is its own collision box. And if I go on the right side here and type collision in the search bar, I can see it created 12 different convex elements. Auto collision is not always the greatest. In this case, it works decent. If you have really complex looking shapes, sometimes the best bet is to do the collision in an external program. Hit the save button. Now we can animate this down. And what I want to do with this button is it's going to come down, click down, and then pop back up just slightly. So it's going to go all the way down to 25. I'm looking right here, the Z-axis, and then it's going to pop back up to 30. Default position is 50. Go to the event graph, create an event, call this event pressed, so like the button is pressed, and we're going to do another timeline. So search for timeline and hit add timeline. Call it anything you want or let it say timeline. I'll just call it button press. The last time we did a timeline, it was for our collectible, and we had a float go to a lerp node. This time we're not going to do the lerp. We're going to animate directly with values in this timeline. Off of here, play from start. Play from start means it'll always play from the beginning of the animation. Double click into the timeline, add new float track. We're going to do a float track because I'm only animating the Z-axis. Right click on the name here and select rename, Z value, something like that. It's going to be a quick animation. We'll start at half a second. Imagine the button being pressed. It's not going to take very long at all. Add a key float, and the first value will be its current default value, which it rests at 50. At time 0, the value will be 50. It disappears because it's so high up in the stack here. Hit this zoom to fit vertical, and now we can see it up there. We can also zoom to fit horizontal, and then use the mouse wheel, can scroll out a little more as well. And then right click anywhere, add another value, and it's going to go down to 25. Let's say at 0.2 seconds, it goes to 25. Actually, let's say it goes to 20. Add one more float, and at the last 0.5 second mark, it's going to have a final rest at 35. With all of these highlighted, right click, do auto, and then we can change this so it's going to go down faster. The button's going to physically move down pretty quick to this point, and then when it gets there, it's going to slowly pop up and then rest at the final destination here. So let's save that. Go to the event graph, drag the button into the grid, and we're going to set relative location. Connect the update node, right click on the vector here and do split pin and put the Z value into the Z location. With that completed, we can just do it right after this print string, call our pressed event. Let's compile, save, and see how it looks. So the click happens a little too slowly, and these need to be raised a little more off the ground. The button's going into the world. So that's how it looks right now. So I think going back into the animation, let's try linear for the first one. When it goes down, I want it to happen in 0.1 second. Come up a lot quicker and then slowly rest. See how that looks? That looks a lot better. So now we can click it once, but now when we get off of it, we want it to pop back up. Where it says Z value, I'm going to rename this to Z value press. And then I want to do another one, track float Z value unpress. And we're going to do something similar. So now it's at 35. So at time 0, we'll start at 35 and add another one here. At 0.1, I'll go down slightly, like to 30. Let's say at 0.25, it goes up to 50. So it's like down and then popping back up to 50. And it's doing it linearly, I think looks the best. Back in the event graph, create a new custom event, call it unpress, and we want to do reverse from end. We need to change this slightly. Off of the direction, just hit equal, and we're going to do equals enum. Hold the B key on the keyboard and press anywhere to create a branch. Plug this in there. On update, if it's going forward, we're going to plug it into the pressed one. Add some reroute nodes. Then I want to copy this, paste it down here. I like to use one node like that to keep it a little cleaner. Off the false node means it's going to go backwards. We can do that. And then the unpressed value will go in the Z here. Let's say it'll unpress after 2 seconds as a test. Off of the press, we can do a delay node, 2 seconds, unpress the button. Let's give it a test. And the reason that looks weird is it's actually because this is backwards. It's doing it from the end and going this way. I think the easiest will just be to invert how this is happening. So at 0.5, it's going to start at 35. And then at 0.4, we'll go down to 30. Then at 0.25, it goes back to 50, something like that. The timeline is going to happen in reverse for this one and go down slightly, up, and that's about it. Test that out. That looks pretty good. I can't trigger it more than once because there's a do once node. Now let's do it so it resets when the character steps off the button. So right now everything's on component hit, the button itself being physically hit. To detect when the player is jumping off the button, ideally we need to add a collision sphere or capsule. With the button selected, go to add, type collision. I'll stick with a collision sphere. In the viewport here, change this to the front view, and radius needs to go up. 120 is looking okay. My button's right here at this level, so I'm turning off snapping just to make the widest point at the button level here. Location, we can type it as 50. Go back to the event graph. On component hit, for pressing the button, still makes the most sense. Let's go to sphere, scroll down and do on end overlap, hit the plus sign, add that. When the player's done overlapping the sphere, then we will unpress this button. Let's delete the delay node. Let's do another print string for off. And again, on other actor, cast to first game character, just to confirm it's the player. And we'll also do this once. And then we'll call the off dispatch, and this will tell the doors that the button's off as well. So it looks something like this. What we need to do also is reset the do once node. Instead of this do once, let's create a variable. We'll call this is pressed. Drag the isPress variable here and check the box, and drag it here and leave it unchecked. Remove these do onces. With B pressed, create a branch. Drag isPressed into here. So if it is not pressed, we will continue. Copy that, paste it down here. And if it is pressed, we will continue. In the sphere, let's just go to collisions real quick and customize it. We'll do custom, ignore everything except the pawn. That seems to be working pretty nicely. The doors are printing the strings that they're opened and closed. So it looks like the variable got stuck at one point. This variable should actually be done after the animation. By holding Alt on the keyboard and selecting the line, I can disconnect it. I'm going to move these down here, somewhere down here. Hold B and press anywhere to create a branch. Off the finish node, I'm going to drag that into this branch here. And then off this direction enum, I'm going to bring that into the condition here. So if it's going forward, when it's finished, we will say it's been pressed, and when it's going backward, which is false, it'll be unpressed. That should prevent some stickiness with the variables when going back and forth on the button quickly. It'll wait until the button's been fully pressed and fully unpressed before setting the variable, which will control when it can be pressed and unpressed again. And then I'll just delete these print strings. They're no longer needed. And we can also move on and off. Put these down here as well. So that should work a lot better. And now it waits for the animation before telling the doors that it's on or off. And it still works. So it can get stuck down if I run off before the animation finishes. What makes the most logical sense here is actually to change some of this around and just remove these branches entirely. We actually don't even need this variable. Sometimes simpler is better. We'll get rid of the isPressed. We'll just do reverse and play, and that might just solve the issue like that. So that's just a lot simpler, and it seems to work fine. So that's all we needed. The doors will only open and close if the animation is allowed to finish. So if the player is quickly running over the button, the doors will never open. They will need to stay on the button for the doors to open. Last thing to do is let's add a little bit of sound. On the default scene root, add an audio component. In this audio component, in the search bar, type click. Just select one of them. I'm going to do the button cue. All of these also have cues. So there's a sound, which is the sound wave itself, and then there's a cue, which does more to the sound wave. We'll get more into audio later in another tutorial, perhaps. But for now, click on button cue, drag off the audio, and type in play. Now it plays as soon as we start the level, which we do not want. So with audio selected, search for auto. We're going to disable auto activate. So when the button's pressed, it makes a sound. And there could be a sound for when it unpresses, but this will work. Just helps the game feel a little bit better. One last thing I want to do, one little polish item. On begin play, we'll create a new begin play node here. We're going to drag off the button base. And from here, we want to create a dynamic material instance. And I want to get element 1, which if I open up the button base, element 1 is this is the red material. And then on the return value, right click, promote to variable, and we'll rename it to button base material, something like that. Now that that's happening on begin play, I'm going to come down here to when the animation finishes, drag off the material reference that we just created. We're going to set scalar parameter by value. When the button is on, if we look at the button parameter here, we have this emissive strength and the emissive color. I'm going to actually edit the material so the color is also this red. So I'm going to copy, right-click copy on the red color and paste it down here for the emissive color. So we just need to type the name exactly as it appears for the emissive strength. We can right-click, copy display name, and then in this parameter name, Control V to paste it in there. And let's just try a value of 10 right now. And then take this entire node, copy it, paste it below, move this out of the way, and we'll make it back to 0 when it's off. And connect this button base material node into the target here. When the button is pressed, there's a glowing ring. Maybe turn it on sooner. To smooth this out, it might be better to take the on version of it and make the on like this. This way we don't see that it's like turning on. So that looks a little bit better. Okay, moving on to the doors. First thing I want to do, let's create like a door frame. Open up the door blueprint. It looks like this. We're binding to our switch. In the components over here, we'll add another one. Add a cube. Make it the parent. This will be door frame, and this will be door. In the viewport, we'll take the door frame. Right now, unparent everything. Scale it so the door frame is aligned on the bottom of the door and has some good margin around the outsides, but we still want to see the door popping through both sides of the door frame. Go to the level, select the actor, go to modeling mode, go to model, hit Boolean. Now it cuts out the door frame to the size of the door. We'll accept that. Now with this new door frame model, click the little folder over here. We'll do S door frame, drag it to meshes, my interactables folder. Now going to the door frame, let's open it up. Let's check the collision. And right now the collision is still a box and the character will not be able to walk through the door. So we're going to have to change that. Just as an example, come into the world. I'm still being blocked from going through the door frame. Let's just see if the auto convex collision will work. That does not look good. So all of this is just not doing what I wanted to do. Let's make sure all the collision is cleared out of there. So what I'm going to do is do it manually in collision, add a box, simplified collision, scale it, drag it, make snapping maybe 1, turn off the scale snapping, and showing wireframe can get a little better look of how it's aligned. I think that's aligned pretty good on that side. Then in collision, we're going to duplicate that one. Why it moved it, I have no idea. And then we're going to do one more box collision for the top. And that should work well for our door frame. So there's 3 boxes and we've left the door frame open for the character. Hit save. Now let's test the door frame. I can walk through it and the walls stop the character. When I did this, it deleted my door. I'm just going to get rid of the door frame. I'll make another door here and I'll attach this back to my switch. It's already attached, okay. Back into blueprints, interactables, going back into the door, we're going to switch out the door frame, mesh, and make sure to reset the scale to 1, 1, 1. And the door can be a child of it. Now that the door frame is created, we can scale the door so that it's the same width. Now doors can open many different ways. They can swing open. We can have it a sliding door that raises or goes to the side or collapse into the ground, be destroyed. Many different options to opening this door. Let's just do a typical like swinging door. We'll create a custom event, open door. With the way that this door is, if we try to open it on an angle, it's going to do it from the center pivot. We actually want to create a new door. Back in the tutorial level, back to modeling mode. Let's add a box, put it next to the door here. We can change these settings right here. I think the width at 130, depth, let's try maybe 10. That looks good. And then the height, 200, 225. So my door, 130, 10, 225. The pivot is at the bottom here. Let's, I'm going to make it on the right side so that it'll swing open. The right will be the hinge. You could do the left if you want the hinges on the left. Accept that. Find it in the folder, rename it S door, right hinge. You can create another one that's maybe a left. Now with that created, I'll get it out of the world there. In blueprints, interactables, go back into the door blueprint. We're going to replace the door with this new S door, reset the scale back to 1, and the positioning should be 65, -80. My height's a little off. I'll just make the scale 1.02, fills the gap. Compile that. Click on the door mesh, go in here, and since this is a new mesh, we have to assign the material. Just find door, assign it as the default material. Now with our door and door frame and the hinge on one side of the door, we can open it. Create a custom event, open door. Let's add a timeline again. Play, just call it swing open. We can also do a custom event, close door. That'll be from the reverse. What's going to happen? Let's go to the viewport. We're going to open it up, maybe 130 from 0. Now in the timeline, add a track. We want this to take only about 1 second to open. Add at time 0, the rotation will be 0. At time 1, it will be 130. Magnify these. It could start quicker and then gradually slow down. Let's just try this. I'll rename this to door movement. Go in the event graph, drag in the door, set relative rotation, right click on the rotation and split it. We're just going to drag this into the Z. So that should be everything we need. Instead of these print strings, we just call open door, delete this one and do close door. So now we have doors opening and closing. And the reason there is a delay here is because close and open is not called until the button animation completes. When I get off the button, the door doesn't start closing until the button animation is done. So there might be some gameplay things here that require there to be less of a delay. That'll have to be programmed in somehow. But when the door is closed, I'm stuck. Right now, the way this is set up, these doors can only be attached to one switch. So we might want to do something a little different and have a way to bind to more than one switch. So let's just do that. Let's make the switch an array. Highlight switch, turn it into an array, change variable type. It's going to do some searching here. X out of that. Now we're just going to for each off the array on begin play here. With control held down, you can drag off these pins and move them into the array element. So now what's going to happen is we can have multiple switches in an array, and on begin play, it'll loop through them all. It'll bind to the dispatches of each of those switches. Let's compile and save that. Let's add one more button over here. We need to rebind these doors. This one on the far right will go to button 2. This door here will go to button and button 3. And then this one, button, and just to mix it up, we'll make it go to button 2. This opens these two doors. This button opens the one door, and this button opens two doors. So now we have quite an intricate little setup here with buttons and doors. We can even start level designing using all of these actors we've created. But we want one more type of switch, which would be like a lever that the player can press a key and interact with. We can put these like on the walls or something, and they can also be used to control doors or platforms. On the interact blueprint, right click, do create child, BP. This will be a lever. Open up the lever blueprint. First thing we need is some sort of mesh. I think I'll do a cylinder right now. And I want some sort of back plate for it. Let's try a cube. Parent the lever to the plate. So the plate will be something small, shrunken down like this. And I'm going to rotate it. The lever will be shrunk down, scaled up like this. While manipulating these meshes, I'm going to just unparent them so I could do this a little easier. And then I want to move this up on the world axis. So I change this little icon to show like a globe, and I can move that up like that. Press it into the box a little bit, and that's starting to look like something. Pile, save. I want to see how large this is in the world. Drag it in. That's a pretty big object. Let's get our character, drag her in, snap the scale here. 0.25 looks to be a decent scale relative to the character. With that knowledge, I go back into the lever. On the root scale, we'll make it 0.25. Then I can put the lever a child of the plate, and there it is. This is a temporary just mesh. We'll model something in a little bit. Let's make the handle the same color as the button. Let's do the back plate. Let's just get this to start working. We're going to do it similarly to how the button works. We need a collision sphere around this lever. Add a sphere collision. The sphere will be a child of the lever. We can make it, let's see, 64. Let's just move the sphere to like the edge of the handle, somewhere around there. Let's make it a little bit bigger. Scale it up a bit so that it's covering front side of the lever here. It needs to be big enough so that it can overlap the character. We don't want the character to have to get too close to it. So I'm going to make it, let's try 128 radius, something like 15. The character will need to be around that close to interact with it. I can even drag it out a little more. Compile that. In the event graph, remove all this. Collision sphere. On begin overlap, we'll add one of those. In the sphere for the collision, just do custom, ignore everything except the pawn. Other actor, cast to our character. If it is the character, let's just flip-flop this, call on and call off. So again, this is inheriting from the interact actor that we created before. If I hit this little magnifying glass, we created the dispatch events on and off, and that's what our button uses, and that's how we're calling those from the button. We're doing that again from this lever. We're going to do something a little different with this one and have an interface set up so that we can require a button click from the character to do this. Temporarily, while getting this started, I'm just going to set it up like this right now. If I move this switch somewhere, we'll just print string, copy paste, lever off. Now, because it inherits from interact, we can also go into our door and change one of these to the lever, or we can add a third element to the array. So when this is on, it should open that door, and when it's off, it'll close the door. So let's just walk next to the lever, and the door's open, and the door's closed. So every time I overlap the lever, it's affecting the door. All right, so we've been at this for quite a while. Follow me on Patreon if you want to download the project files. The next part 4, will focus on the lever, and it will entail setting up some input for the player to be able to press a button, and also using interfaces. Exciting stuff. Stay tuned. That'll be it for this one. Take care.